Okay, so today we're going to continue talking about distribution, but it's going to look a little bit different. So now we're going to do something called double distribution. Okay, we're going to build off of what you already know, just like we typically do. So if you were to think of something like 4 times x plus 3, this would clearly be a distribution question, and you would multiply 4 times x, and then you would multiply 4 times 3, and you would get 4x plus 12. Well, now we're going to think about something similar to that, but we're going to expand on it. So now, if I had the x plus 3, but instead of multiplying it by a single monomial, I'm going to multiply it by another binomial like x plus 4. Okay, so now this is where the idea of double distribution comes from. Remember that if that was just a 4, you would simply distribute the 4 to both pieces, so that that part would be 4x plus 12. But now what we also have to do is distribute this x to both pieces in the other binomial. So I'm going to do x times x, and I'm also going to do x times 3. So altogether, notice I have 4 rainbows that I've made, and that's going to be, if I multiply things out, so I'll do the x times x first, which is x squared, and then I'm going to do x times 3, which is plus 3x, and then I'm going to do 4 times x, which is plus 4x, and then of course 4 times 3 is 12. Now when you do this, notice that the two things in the middle are like terms. So I'm going to put those together, and so my final answer is x squared plus 7x plus 12. Multiplying two binomials produces a trinomial. And again, these things are equal. They're equivalent ways of writing it, just in different formats. This is expanded form, this is factored form because it's got the parentheses that are being multiplied. Okay? Another way to think about that, if it helps you, if you think back to the way you learned multiplication in elementary school, you can do something called the area model. And I can do that here too. If I was to create a rectangle, and I'm going to split this rectangle because my first binomial was x plus 4, and my second binomial was x plus 3. So if I were to create something like this, the area model says find the area of this little rectangle right here, which would be length times width. X times x is x squared. Find the area of this box here, it would be x for the width and 4 for the length, so multiplying that would be 4x. Here would be 3 times x, which is 3x. Here would be 3 times 4, which is 12. And then keep in mind, again from earlier years, the sum of all the parts will give me the area of the entire thing. So this, if I was to want the area of the entire thing, would be x squared plus, keeping in mind that these are like terms, so it would be 7x and then plus the 12. And I'm really done because none of these are like terms. Notice I got the same answer. Whichever method works better for us is perfectly fine. There's even a third method if you're interested in seeing it in class tomorrow. So this is all we're going to be practicing today, and it can get kind of cumbersome with the coefficients, but it doesn't change the way we think about things. So if I was to do something like x plus 2 times x plus 3, notice that these are both binomials. Okay, so I'm going to do double distribution. In the past, I would have multiplied 2 times x and 2 times 3. Now I'm also going to multiply x times x and x times 3. Both terms in this quantity are getting multiplied into both terms in this quantity. So when I do that multiplication, x times x is x squared, x times 3 is plus 3x, 2 times x is plus 2x, and 2 times 3 is plus 6. Again, recognize that I have these two middle terms that go together, so I'll have x squared plus 5x plus 6. This product is equal to this trinomial. Okay? It works with negatives, so if I was to do x plus 4 times x minus 9. Okay? That would be, if I multiply x times x, I get x squared. X times negative 9 is minus 9x. 4 times x is plus 4x. And 4 times negative 9 is negative 36. Notice that these two middle terms still go together. So this is going to give me x squared minus 5x minus 36. If you were to choose to use the box method, that would do the exact same thing. You should get the same answer. Okay? All right. We can even do it with something like 3x minus 4 times 2x plus 1. It doesn't change the way we do things, we just have to remember our exponent rules. So I'm going to distribute the 3x to both parts. I'm going to distribute the negative 4 to both parts. So when I do that, 3x times 2x is 6x squared. 3x times 1 is 3x. Negative 4 times 2x is negative 8x. And negative 4 times 1 is minus 4. Look, we still have these two middle terms that get combined. So this is actually going to be equal to 6x squared minus 5x minus 4. Okay? What happens if we have just letters? Actually, why don't you try one or two of these on your own first? So how about you try 2x plus 3 times x minus 5. Pause the video, multiply those out, and see what you get. Okay, you should have gotten 2x squared minus 10x plus 3x minus 15, noticing that these get combined to give you 2x squared minus 7x minus 15. Okay? How about you try x minus 7 times 3x plus 4. Multiply that out, pause the video, come back and see if we got it right. Okay, you should have gotten 3x squared plus 4x minus 21x minus 28. These go together, so your final answer should be 3x squared minus 17x minus 28. Noticing, of course, that none of those are like terms. Okay. Now let's look at it if we make it a little bit more complicated, maybe, by putting just some more letters in there. So if I were to do something like 5a plus 3b times 4a minus b, does it really change the way we think about it? I hope not. I'm just going to do 5a times 4a, which is 20a squared. And then I'll do 5a minus times negative b, which is negative 5ab. And then I will do 3b times 4a, which is positive 12ab. And then I'll do 3b times negative b, which is negative b squared. Okay? Do I still have like terms? Notice this is AB and this is AB. Those are like terms. So these get combined. My answer should be 20a squared minus plus 7ab minus b squared. Okay? Again, these are equivalent. Alright, so why don't you please try 4x plus y times 3x minus 4y. And then why don't you try negative x plus 4 times 4 plus 3x. Try those two, pause the video, come back and see the answers. This one should be 12x squared minus 16xy plus 3xy minus 4y squared. These are like terms because they're both xy's, so it's 12x squared minus 13xy minus 4y squared. This one, I'm going to draw my arrows because things are in a little bit different order. Okay, so when I multiply negative x times 4, I get negative 4x. Negative x times 3x is minus 3x squared. 4 times 4 is 16. 4 times 3x is 12x. So I'm going to rearrange these and put them in the order I'm used to. But I do recognize that this right here and this right here are my like terms. So I'm going to have negative 3x squared plus 8x plus 16. Okay? So what do you think about 4x minus 3 squared? Come to class tomorrow and see what you think about that. So we are double distributing binomials. I will see you tomorrow.